Oh, gosh.
Oh, mate, right. So, okay. This is why we'll try not to keep it too complicated for too long, but this is so effing cool. This was, God, I don't even know how I worked it out. It was just like, it was like a eureka moment. I think I was in the bath, actually. So, whatever. I'll tell you what. We can finish off what we're talking about a moment before in this clusterfuck of images. If we go to the bottom right, we'll see two swastika-looking images, and if you go one up, we can see that same triangle, that same trapezium, and all the angles and all the other various things around it, just as proof. There's two Pythagorean triangles in the center and these two extra little triangles on the outside. That triangle is that angle, blah, blah, blah. There you go. Right. Now, here's the cool thing. For a long time, I'd understood that the basic fundamental building block of all this stuff, the basic pixel, was the 3-4-5 Pythagorean triangle. It's famously used to draw many shapes. It's famously in the body. It's famously a Masonic symbol. We can see that Masonic symbol in the top right, and they call it Euclid's 47th problem. I think it is for them. If it is his 47th. Yeah, I think it is. So that's what they call it. So there's a little gold-looking thing in the top right there. Next to it is an Egyptian version. And they called those four... there's three squares around the outside of this triangle.
Yes.
And that's to prove that A squared plus B squared equals C squared.
Yes.
Those are the squares mapped out. And you find if you count all the measurements that the shorter line... So there are three lines. They're red, white, and blue, let's say. The red is 3, the blue is 4, and then the 5 is this mystery thing that you can work out by adding the 3 and the 4 together, the square of the 3 and the 4 together. In Egypt, the 3 was Osiris, the 4 was Isis, and then they got married and had the son Horus. And this is what it was called. This is famously one of their mysteries.
Right.
Now, we've talked about these numbers, 72, 216, 432, 5040, all these numbers. And when you start comparing them to each other, you start to realize that there are two sets of numbers. One contains the 432s, etc. And then you get this 144 and all these other numbers. So just something in my head went, one's male and it's like one's male and one's female. Can you see it now?
I'm seeing it now.
Let's not jump to it. So I'd realised that because all these 9s are involved, for the male, all these numbers, all the male numbers as I saw them, plugged in to that shorter side, to the red side in the right-hand corner.
Yeah.
All the female numbers plugged into the female side, and then you just, it's so harmonic and beautiful. So we get these numbers that are looking a mess there. So here we go. Here's how I worked it out, right? On the pillars, it says IHS, as in Jesus, Jesus. And that was at one side of Jesus' hand. He's on the cross. If you look in the top left-hand corner there, you can see IHS. On his left hand was IHS. On the right hand was a serpent. But and you can see the serpent in green there. And the more I looked at this serpent, I'm like, it says UHS. Can you see that?
Yeah.
So in Gematria, which is transposing letters to numbers, IHS is equal to 216. UHS was equal to 288. I had my male and my female numbers. Now, if we look in the central column where we've got red and blue numbers and then a white number next to it, we can see there's a column that says 216.
In red, yeah.
And then 288 in blue. And then you get 360. Well, if you plug those numbers into the Pythagorean triangle, 216 on the masculine side, 288 on the other side, you get 360 on the sun side, on the Horus side.
Yeah.
And then all these numbers, I mean, you can look at that to your heart's content, but what ends up happening is through the area and the perimeter and what's called the H, which is annoying, I'll not go into it, but the hypotenuse.
Hypotenuse, yeah.
you get all these numbers. They're even announcing that 216 will be ahead. So if you look on that first column, 486, 108, 216, and then you'll see so many down, you get 216, and then it's the same amount next when that number will announce that it's coming up again. If you get me, there's a pattern with all these things. So that, I was just like, oh, God.
Yeah, 86.4, skip 1, 864. And then we get announced 172.8, skip 2, 1728. It's the harmony.
It's the literal harmony.
And what's great about all these numbers, let's take 1728. 1728, let's add them up. 8 plus 2, 1 plus 7 plus 2 plus 8 is 18. 1 plus 8 equals 9. Let's take another one. 3, 4, 5, 6. 3 plus 4 is 7. 7 plus 5 is 12. 12 plus 6 is 18. 1 plus 8 equals 9. And this multiplier of 9, I've tested this. This works to 7 decimal places. Like if you times 9 by 13,476,371.67371.
2.
Times that by 9, and your result, take all those numbers, add them together, it'll be divisible by 9.
Yeah.
I've tested it to the point where the calculator doesn't work
anymore.
What if you so you start with 3 or 4 by 9 at the top, right? What if you did 3 or 4 times
Where
7?
am I? Sorry. What were you pointing me to? Sorry.
Middle, just where you're getting your numbers.
Yeah.
At the start.
Here.
So your starting is.
Yeah. Oh, so right. So what it is so here's the fundamentals of it. So 3 times 9 is 27.
Yeah. 4 times 9.
And then you're doubling it every time. 27, 54, 108. Do you get me? So it's a doubling of 4 times, because it's a 3, 4, 5 triangle.
Yeah.
So one side's got 3 times 9s on it, doubled.
Yeah.
The other side's got 4 times 9 on it, and then doubled. And the reason for it is because of all this. Not the reason for it, but the reason that they did it was because it's all divisible by so many numbers. It's very complex to go into. Quite simple. If I had half an hour with you, you'd totally get it. But half an hour on here is not necessarily time well spent.
Do you get similar patterns with, like, if you did 7, 3 and 4 times 7, or 3 or 4 times?
It doesn't work
3.
the same. It's because of that 9. Basically,
the 9 is magic.
Yeah.
It's like I've tried this with because you think you're seeing things. So you try it, you test it against other things. So you'll do the 7 times tables or the 13 times tables or anything, but there's something special about the number 9, basically.
I think, aren't we like programmed to see patterns as well? So when we get to an actual mathematical pattern, which this is, it's like triggers you.
Yeah, it really triggers you.
It rings a bell.
Yeah. Well, because it's in you. It literally is your structure. So it was resonating is what it's doing.
Look at the numbers. 90 degrees, a right angle. 180.
Mm-hmm.
That's
half a circle.
Circle.
Yeah.
360 is a circle.
Yeah.
720 is your TV.
Yeah.
Why is a TV 720? It's because of this.
And
it's not because Samsung decided it's going to be 720 or 2080p.
It's because of those 3, 4, 5 triangles, because you can scale them up so easily.
TVs used to be a 4:3 ratio back before widescreen.
4:3.
Yeah.
And it was 432 pixels, as it were,
Yeah.
across 432.
432.
Yeah. So the Pythagorean right angle triangle is totally encoded in the swastika. If you look in the bottom right hand corner, is there straight away. There's lots of other ways of drawing it that we'll see in a little while. But another thing about this, we've talked many times about this angle, and this angle is the reason all this stuff's encoded. So you can see there's in that black box there. In the grey box, sorry, if you go left a little bit, there's some white writing in the top right hand corner of that box. It says 1440 on it. So yeah, that one. Could you read what it says for me?
What, over here?
Yeah. So what I've done is made a little list of. We've seen all these triangles, and they've all got these angles that are pointing at the angle of the axis of the Earth. So what I did was make an actual list, because they're all slightly off, you see. So if you can read that for me. That'd be lovely.
Right, pyramid equals, I think that's 51.5 degrees.
Yeah, so you'd half that and get the angle of the axis.
26.25.
Is
Yeah,
that
that
you've
did the
done it,
half.
yeah,
That's
yeah.
the axis. So pattern equals 51.43 degrees.
okay. The pattern's this thing that I've discovered that we'll see very soon.
Right. Pythagoras 345 triangle equals 53.13 degrees.
So again, you half that and you get the
JHV8, so that's the Jehovah
triangle.
triangle. 23.97 degrees.
There you go.
And then the heptagram triangle is 25.6 degrees.
Yeah.
So
A heptagram's a 7-sided shape, which is absolutely coming up.
right. And again, going back to these sacred numbers, I can't resist this stuff here because, again, it's relating to time. 24 hours in a day, 60 minutes per hour, 1,440. Where is it?
Minutes in a day, there it is.
There we go.
Central column,
There
yeah.
we go. 1,440 minutes per day, 60 seconds in a minute, 3,600 seconds per hour.
260 again.
360.
864 is another one.
886,400 seconds per day.
864 is the size of the Earth in miles.
864.
Yeah.
And, this will carry on. Oh, there we go. 864. It's there for a reason.
It's so funny, really.
And
you get
these
used
work.
to all this.
What's the processional cycle? 25,920. Can we find that anywhere? 2592.
I think we might have skipped over this previously. Did I tell you that? Just go to the next slide for me, just in case I'm gonna say something silly. So I've totally missed something off a previous episode, and this is so interesting.